APIs are like doors into your system, and if you leave those doors unprotected, attackers can walk right in. They can access user data, overload your servers, or even damage your entire system. So in today's video, let's look at 7 proven techniques that can help you protect your APIs from unwanted attacks. The first technique is rate limiting. Rate limiting controls how many requests a client can make within a specific period of time. For example, you might allow a user to make 100 requests per minute, but the moment they send request number 101, the API temporarily blocks additional requests and asks them to try again later. Without rate limiting, attackers can send thousands of requests per minute. This can overload your API, take your system down, or allow someone to brute force sensitive endpoints such as login or OTP verification APIs. And you should not always apply the same rate limit to every endpoint. For example, fetching comments may allow more requests, but creating comments, submitting forms, attempting to log in, or requesting an OTP should usually have stricter limits. You can apply these limits per user, per API key, or per IP address. If one IP address repeatedly crosses the allowed limit, you can temporarily block requests coming from that source. But there is one more problem. What if the attacker uses multiple bots? Each bot may have a different IP address. Individually, every bot may remain within its limit, but together, they can still overwhelm your system. That is why you also need infrastructure level protection such as global rate limits, load balancers, CDN protection, and DDoS mitigation services. The second technique is CORS, which stands for Cross-Origin Resource Sharing. CORS controls which websites are allowed to call your API from a browser. For example, if your frontend is hosted at app.yourdomain.com, your API can allow browser requests from that domain while rejecting requests from unknown origins. But remember, source is not authentication. It only adds a browser level restriction. Tools such as Postman, curl, mobile apps, and backend servers are not blocked by browser CORS rules. So your API still needs proper authentication and authorization. The third technique is protecting your API from SQL and NoSQL injection attacks. Injection attacks happen when user input is directly inserted into a database query. An attacker may modify the input to bypass your checks, read sensitive data, change records, or even delete information from your database. To prevent this, always use parameterized queries, prepared statements, all the safeguards provided by a trusted ORM. Never concatenate raw user input directly into your database queries. The fourth technique is using a web application firewall, also known as a WAF. A WAF acts as a gatekeeper between the internet and your API. It filters suspicious traffic before it reaches your application. For example, a WAF can detect and block common attack patterns, suspicious payloads, unusual request behavior, or requests coming from known malicious sources. Valid requests continue to your API, suspicious requests are blocked or challenged before they consume your server resources. The fifth technique is restricting private APIs through a VPN or a private network. Not every API should be publicly reachable from the internet. For example, your customer-facing APIs may need to remain public, but internal APIs, admin dashboards, database tools, and operational endpoints should often be accessible only from a private network. An employee connected to the company VPN can access these internal APIs. A random user on the public internet cannot. The sixth technique is SERF protection. SERF stands for Cross-Site Request Forgery. Imagine that you are logged into your bank account in one browser tab. Your browser already has a valid session cookie. Now, you open a malicious website in another tab. That website attempts to trigger a hidden request to transfer money from your bank account. The malicious website does not necessarily need to read your cookie directly. In some cases, your browser may automatically attach the existing cookie when sending the request. To prevent this, applications using cookie-based authentication commonly use SERF tokens, secure cookie settings, and origin checks. The API validates that the request genuinely came from the trusted application before processing any sensitive action. The seventh technique is preventing XSS attacks. XSS stands for cross-site scripting. Imagine that your application has a comment section. A normal user may submit a comment such as "nice picture." Your API stores that comment in the database and displays it when other users open the page. But what if an attacker submits malicious JavaScript code instead of a normal comment? If your frontend renders that input without proper escaping or sanitization, the browser may execute the attacker's script when another user loads the page. That script could attempt to steal sensitive information information, perform unwanted actions, or manipulate the page. Avoid rendering untrusted HTML. Use secure cookie settings such as HTTP only and apply a content security policy wherever possible. So these are 7 important techniques for protecting your APIs. Rate limiting, COS configuration, injection prevention, web application firewalls, private network access, CSRF protection, and XSS prevention. But remember, API security is not about using just one technique. It is about adding multiple layers of protection so that one weakness does not compromise your entire system. And that's it for this video. I hope this gave you a clear idea of how API security works in real-world systems. I'll see you in another video.